The functions f and g are defined by f of x equals to ln 2x minus 9, where x is greater than 9 over 2, g of x equals to 2 ln x minus ln d, where x is greater than 0 and d belongs to the positive real number subset. State the equation of the vertical asymptote to the graph of y equals g of x. The graphs of y equals f of x and y equals g of x intersect at two distinct points. Show that at the points of intersection x squared minus 2dx plus 9d equals to 0, hence shows that d squared minus 9d is greater than 0. Find the range of possible values of d. Okay, so for a, we have to remember what a vertical asymptote is. Okay, a vertical asymptote is basically a straight line on the x-axis that is being approached by a function but will never touch it. Okay, so we're given a bit of a clue here where x has to be greater than 0, and if we try input 0 into x here, it doesn't exist. So since we know that, then our x here is equal to 0. For b of I, show that at the points of intersection x squared minus 2dx plus 9d equals 0. Remember, when it says show that, that means we're trying to get this. And when we're trying to get this, how do we get this quadratic equation? Well, we have to find the points of intersection of two functions, we have to equate them to each other. So our f of x is equal to g of x. And here, our f of x is ln 2x minus 9 is equal to 2 ln x minus ln d. Now we have to remember that our a log b is equal to log b power a, and we also have to remember that log a minus log b is equal to log a over b. We have to remember some of our logarithm equations, or you can check them in your formula booklet. Okay, so following the rules that we have here, ln 2x minus 9 equals to ln x squared, because we have to move this here, minus ln d. And now that we have that, we can turn them, it's a subtraction, which turns into a division here, x squared over d. Now we can cancel out the ln's, which we get 2x minus 9 equals to x squared over d. Now remember, we're trying to get this equation right here. And to get that, we move d to the other side, in which we'll get d times 2x minus 9 equals to x squared. And after that, we can multiply them together. 2dx minus 9d equals to x squared. Now we move both of these values to the other side, and we would get x squared minus 2dx plus 9d is equal to 0. And now let's move on to this. That is our answer for b of I. D squared minus 9d is greater than 0. Okay, so we can already see from here that it is a discriminant. So a discriminant is b squared minus 4ac. Okay, just to make it easier for you, I can see this. A is this value right here. This value here is b, and this value is c. All right, and now that we know that, we can substitute them into the equation right here. 2d squared minus 4ac. All right, and after that, we can just expand them. So we would get 4d squared minus 36d. And simplify, we would have d squared minus 9d. And since it is greater than 0, that means just because it is greater than 0 because it has two distinct points. Sorry. So if it has two distinct points, it would be greater than 0. If there's one distinct point, it would be equal to 0. And if there are no distinct points, it would be less than 0. Okay, we have to remember that, since that's not shown in the formula sheet. Okay, so that means that our discriminant is greater than 0 because there are two distinct points. After knowing that, we would have d squared minus 9d is greater than 0. And for triple I, we have to find the range of possible values of d. So let's take this, minus 9d is greater than 0. Okay, let's try factor d out and think about this, okay? Uh, Technically, we could do negative values, and when we multiply a negative value with each other, we would have a value that is greater than 0. So it does work, but if we look up here, d belongs to the positive real number subset, okay? So that means that the value of d has to be positive. So we cannot use negative numbers. Now, if we try a value that is in between 0 and 9, for example, if we have 8, which is a really easy one, we would have 8 times minus 1, and that would equal to minus 8, which does not suffice for this equation right here, okay? But if we have a value that is greater than 9, okay, hold on, let me process out. This does not work, so we have a value that is greater than 9, like 10, 10, 10 minus 1, we would have 10 times, wait, 10 minus 9, sorry. We would have 10 times 1, which is 10. And this works for all the values that are above 9, okay? So that means that our range of values of d to suffice for this equation is d is greater than 9. Okay. The following diagram shows parts of the following diagram shows part of the graphs of y equals f of x and y equals g of x. The graphs intersect at x equals p and x equals q, where p is less than q. In the case where d equals to 10, find the value of q minus p. Express your answer in the form a root of b, where b belongs to the positive integer subset. Okay, so for this one here, we have to think about this a little bit more logically. What is q minus p? So q minus p, well, let's first define q and p. Q and p, as we can see from this graph right here, are the two distinct roots that intersect between f and g. Okay, so now that we realize that, we're actually trying to find the x's right here and here. And when we're trying to subtract p from q, we can understand that it would be this out of this as a whole. Okay? That means we are left with this right here, which is the distance between q and p. Because, okay, so the green, let's say the green is q and the red is p. When we subtract p from q, it is the distance in between those 2 points. All right? So from here, let's take our quadratic equation that we got from before, which is x squared minus what? Minus 2dx plus 9d. Minus 2dx plus 9d is equal to 0. Okay, and let's substitute our d right here. X squared minus 2, 10, x plus 9, 10 is equal to 0, which is also the same as x squared minus 20x plus 9d equals to 0. Now let's take our quadratic equation here, which is minus b plus minus b squared minus 4ac, sorry, equals to 2 over 2a. Over 2a, and we would just substitute our values into our quadratic equation here, which then we would get minus 20 plus minus 20 squared minus 4, 90, and sorry, over 2 times 1, and doing that, simplifying even further, 20 plus minus minus 20 times minus 20, that would be 400 minus 360 over 2. And after that, we would have 20 plus minus roots of 40 over 2. Now, taking we can actually take 2 out. So it's 10 over 2. Because keep in mind, all right, so how do we get this, okay? Root of 40 is the same as root of 4 times 10, which we can then take the root of 4 out, which we would be given root of 2 times root of 10, okay? And after that, we can just cancel these out, which we would get 10 plus minus root of 10. Okay, so let's see the things that we have to see. P is less than Q, okay? So that means that our P here is actually 10 minus root of 10. And Q is equal to 10 plus root of 10. And since we're trying to find the value in between these two, we would have to find Q minus P, okay? So Q minus P is equal to 10 plus root of 10 minus 10 minus root of 10, in which we would get root of 10 plus root of 10, which is the same as 2 root of 10. And this is our answer.